Rennet for the apple varieties. See Rennet. Rennet RNT is a complex set of enzymes produced in the stomachs of ruminant mammals. Chymosin, its key component, is a protease enzyme that curdles the casein in milk. This helps young mammals digest their mother's milk. Rennet can also be used to separate milk into solid curds for cheese making and liquid whey. In addition to chymosin, rennet contains other important enzymes such as pepsin and a lipase. Rennet is used in the production of most cheeses. The mammal's digestive system must be accessed to obtain its rennet. Non-animal alternatives for rennet are also available. Molecular action of rennet enzymes. Extraction of calf rennet. Traditional method. Modern method. Alternative sources. Vegetable microbial fermentation. Produced chymosin. Non-rennet coagulation. See also references. Footnotes. Bibliography. External links. Molecular action of rennet enzymes. One of the main actions of rennet is its protease chymosin cleaving the kappa-casein chain 1. Casein is the main protein of milk. Cleavage causes casein to stick to other cleaved casein molecules and form a network. It can cluster better in the presence of calcium and phosphate, which is why it is occasionally added in cheese making, especially from calcium phosphate per goat milk. The solid truncated casein protein network traps other components of milk like fats and minerals to create cheese. In digestion, it is followed by other proteases cutting casein further to ultimately release and absorb the component amino acids and minerals. In a nutshell, curdling is chymosin cleaving casein, a process that is part of natural digestion and cheese making. Extraction of calf rennet. Calf rennet is extracted from the inner mucosa of the fourth stomach chamber, the abomasum, of young, unweaned calves as part of livestock butchering. These stomachs are a byproduct of veal production. 2. If rennet is extracted from older calves, grass-fed or grain-fed, the rennet contains less or no chymosin, but a high level of pepsin and can only be used for special types of milk and cheeses. As each ruminant produces a special kind of rennet to digest the milk of its own species, milk-specific rennets are available, such as kid goat rennet for goat's milk and lamb rennet for sheep's milk. Traditional method. Dried and cleaned stomachs of young calves are sliced into small pieces and then put into salt water or whey, together with some vinegar or wine to lower the pH of the solution. After some time, overnight or several days, the solution is filtered. The crude rennet that remains in the filtered solution can then be used to coagulate milk. About 1 gram of this solution can normally coagulate 2 to 4 L of milk. Modern method. Deep frozen stomachs are milled and put into an enzyme extracting solution. The crude rennet extract is then activated by adding acid. The enzymes in the stomach are produced in an inactive form and are activated by the stomach acid. The acid is then neutralized and the rennet extract is filtered in several stages and concentrated until reaching a typical potency of about 1:15,000, meaning 1 gram of extract can coagulate 15 kilograms of milk. 1 kg of rennet extract has about 0.7 grams of active enzymes. The rest is water and salt and sometimes sodium benzoate, E211, 0.5%, 1.0% for preservation. Typically, 1 kilogram of cheese contains about 0.0003 grams of rennet enzymes. Alternative sources. Because of the limited availability of mammalian stomachs for rennet production, cheese makers have sought other ways to coagulate milk since at least Roman times. The many sources of enzymes that can be a substitute for animal rennet range from plants and fungi to microbial sources. 3. Cheeses produced from any of these varieties of rennet are suitable for lacto-vegetarians. Fermentation-produced chymosin is used more often in industrial cheese making in North America and Europe today because it is less expensive than animal rennet. 4. Vegetable. Many plants have coagulating properties. Homer suggests in the Iliad that the Greeks used an extract of fig juice to coagulate milk. 5. Other examples include several species of gallium, dried caper leaves. 6. Nettles, thistles, mallow, and ground ivy. Enzymes from thistle or canard are used in some traditional cheese production in the Mediterranean. Phytic acid, derived from unfermented soybeans, or fermentation-produced chymosin, FPC, may also be used. Vegetable rennet might be used in the production of kosher and halal cheeses, but nearly all kosher cheeses are produced with either microbial rennet or FPC. Citation needed. Commercial. So, called vegetable rennets, usually contain an extract from the mold Rhizomucormidae. Microbial. Some molds such as Rhizomucormidae are able to produce proteolytic enzymes. These molds are produced in a fermenter and then specially concentrated and purified to avoid contamination with unpleasant byproducts of the mold growth. The traditional view is that these coagulants result in bitterness and low yield in cheese, especially when aged for a long time. Over the years, microbial coagulants have improved a lot, largely due to the characterization and purification of secondary enzymes responsible for bitter peptide formation, non-specific proteolytic breakdown in cheese aged for long periods. Consequently, it has become possible to produce several high-quality cheeses with microbial rennet. 7. Cheeses produced this way are suitable for vegetarians, provided no animal-based alimentation was used during the production. Fermentation produced chymosin. Because of the above imperfections of microbial and animal rennets, many producers sought other replacements of rennet. With genetic engineering, it became possible to isolate rennet genes from animals and introduce them into certain bacteria, fungi, or yeasts to make them produce chymosin during fermentation. The genetically modified microorganism is killed after fermentation and chymosin isolated from the fermentation broth, so that the fermentation-produced chymosin, FPC, used by cheese producers does not contain a GMO or any GMO DNA. FPC is identical to chymosin made by an animal, but is produced in a more efficient way. FPC products have been on the market since 1990 and, because the quantity needed per unit of milk can be standardized, are commercially viable alternatives to crude animal or plant rennets, as well as generally preferred to them. 8. Originally created by biotechnology company Pfizer, FPC was the first artificially produced enzyme to be registered and allowed by the U.S. Food and Drug Administration. 9. 10. In 1999, about 60% of US hard cheeses were made with FPC. 11. And it has up to 80% of the global market share for rennet. 12. The most widely used FPC is produced either by the fungus Aspergillus niger and commercialized under the trademark Chimax registered sign. 13. By the Danish company CHR Hansen, or produced by Cluiveromyces lactis and commercialized under the trademark Maxirin registered sign. 14. By the Dutch company DSM. FPC is chymosin B, so is more pure than animal rennet, which contains a multitude of proteins. FPC can provide several benefits to the cheese producer compared with animal or microbial rennet, such as higher production yield, better curd texture, and reduced bitterness. 8. Cheeses produced with FPC can be certified kosher 15, 16, and halal 16, and are suitable for vegetarians if no animal-based alimentation was used during the chymosin production in the fermenter. Non-rennet coagulation. Many soft cheeses are produced without use of rennet, by coagulating milk with acid, such as citric acid or vinegar, or the lactic acid produced by soured milk. Cream cheese, paneer, and rubing are traditionally made this way. See category, acid-set cheeses for others. The acidification can also come from bacterial fermentation such as in cultured milk. Citation needed. Vegan alternatives to cheese are manufactured without using animal milk but instead use soy, wheat, rice or cashew. These can be coagulated with acid using sources such as vinegar or lemon juice. 17, 18, 19, 20. See also cheese junket, dessert, pepsin milk,